the
intermediate
value
theorem
by Emma Mateer
and just free rhyme furry.
The I.V.T.
The I.V.T. If function f is continuous for all x values in the closed interval bracket a comma b bracket and y is a number between f of a and f of b, then there is a number x equals c in parentheses a comma b parentheses for which f of c equals y.
Y equals x squared, a continuous function. I.V.T. says there is a value x equals c between 2 and 3, where f of c equals 5 because f of 2 equals 4 and f of 3 equals 9. So x squared equals 5, and when you get the square root of both sides, you are left with x equals the square root of 5, QED. And here's the graph. An open interval versus a closed interval. An open interval does not include its endpoints, and it's indicated with parentheses. A closed interval includes its endpoints, and it's indicated with brackets. These two number lines at the bottom show the difference visually. A continuous graph can be drawn without picking up the pencil because they don't have any breaks or gaps. A discontinuous graph is drawn by picking up the pencil. It has breaks and gaps which have different names assigned to each.
Use the intermediate value theorem to prove that there is a real number equal to the square root of 7. That is, prove that there is a number c such that c squared equals 7. We are going to let f of x equals x squared. The I.V.T. applies because f of x is a polynomial and all polynomials are continuous. And then f of 1 equals 1 squared, that equals 1, and f of 2 equals 2 squared equals 4. So f of 1 is greater than 3 and less than f of 2, and 1 is greater than and equal to c and less than and equal to 2. Therefore, there is a number c between 1 and 2 such that f of c equals 3. This shows that c equals the square root of 3, QED.
Explain why the I.V.T. applies on the given closed interval, then find an approximation for the value of c in the corresponding open interval for which f of c is exactly equal to the given y value. Illustrate by graph. F of x equals x minus 5 to the power of 4 plus 1, brackets 3, 6, y equals 7. This problem will be divided into 3 parts. Part 1. Explain why the I.V.T. applies on the given closed interval. The I.V.T. applies on brackets 3, 6 because f is a polynomial function, and polynomial functions are continuous for all x. Part 2. Find an approximation for the value of c in the corresponding open interval for which f of c is exactly equal to the given y value. Y equals 7. We will be using our calculator. Type in the equation for y1 and 7 for y2 because y equals 7. Then we will go to second calc where we will scroll down to intersect. We will use the intersection on the left because the right side shows that the intersection is not in the interval. The intersection is x equals 3.4349154. X equals c. Illustrate by graph. Here is the graph. Glue and Gly run the 1,000-meter race. 1 minute after the race begins, Gly is running 20 kilometers an hour, and Glue is running 15 kilometers an hour. 3 minutes after the race begins, Gly has slowed to 17 kilometers an hour, and Glue has speeded up to 19 kilometers an hour. Assume that each runner's speed is a continuous function of time. Prove that there is a time between 1 minute and 3 minutes after the race begins at which each one is running exactly the same speed.
Let f of t equal Gly's speed minus Glue's speed. Gly at f of 1 equals 20 and Glue at f of 1 equals 15. F of 1 equals 20 minus 15, which equals 5. That's positive. Gly at f of 3 equals 17 and Glue at f of 3 equals 19. F of 3 equals 17 minus 19, which equals negative 2, which is negative.
The speeds are assumed to be continuous, so f is also continuous and the I.V.T applies. Therefore, there is a value of t between 1 and 3 for which f of t equals 0. This shows that glue and glide are going at exactly the same speed at that time.
We chose this content to explore the different parts of the intermediate value theorem and
to get a better understanding.
the project enhanced our understanding of the intermediate value theorem because it helped us go deeper into the different parts of the theorem.
This project improved our vocabulary and our understanding of the theorem. It also improved throughout research.